Section 1.3, modeling with linear functions. Hey, today we're going to review a little of our line knowledge from Algebra 1, and then we're going to look at some different ways of modeling data using linear equations. We're going to briefly talk about how to do it by hand, but then I'm going to show you some tricks and tools to use your calculator to find those models. Okay, first let's go ahead and let's review. We'll talk about our objective. Our objective is we're going to write equations of linear functions using points, slopes, and y-intercepts. And we're going to find the lines of fit and the lines of best fit given some real-life data. Okay, so first we're going to review our Algebra 1 skills, okay, and finding equations of lines. Okay. So first we have our slope-intercept form. This is the one that's most often remembered. This is if you know the slope. Again, our m right here is our slope, and our b right here is our y-intercept, where it crosses the y-axis. This is the easiest one to remember, y equals mx plus b, but it's actually one of the least useful. Normally we can very easily find the slope. Again, remember, slope is the change in y over the change in x. So normally we can very easily find the slope either from the graph or from the points, but the y-intercept is something that we don't always know. We don't always know that y-intercept. So this next form, the point slope form, is really the most useful. So right here, this is when you know the slope. Again, m right here is still our slope, but the point x1, y1, x1 comma y1, is any point on the line. So all I really need to know is the slope, or find the slope from the line, and then I need to just know any point on the line. Okay, so this one is really our most useful. So let's go ahead and let's write that. This one here is really the most useful. And this is the one that I really encourage you to put in your long-term memory. Y minus y1 equals mx minus x1. So this way, if you're just given 2 points on the line, either from the graph or from a table, first you find the slope by, again, taking change in y over change in x. And then you use the point slope form. You put one of those points, and it doesn't matter which point you use, you put that up in your point slope form to find your equation. Okay, so let's go ahead and let's do an example finding the equation of a line. Okay, so here, this graph shows the distance Allison hiked in X hours. Write an equation of the line and interpret the slope. Okay, so first things, this is a two-part question. First, we need to write an equation for the line, and then we need to interpret the slope once we find the slope. Okay, so first things first. Let's look at our graph over here. It looks like it starts here at 0, 0. So I'm just going to plot some points down. We know the point 0, 0. And we also know the point 7, 24.5. Okay. So we really know 2 points off of this graph. So let's go ahead and let's use the point slope form. So let's write that down first. Y minus y1 equals mx minus x1. So I need to find the slope, m, and I need to have a point. Okay, so we already have 2 points, so I can use one of the two, but now we need to find the slope. Since we have a nice graph, I'm just going to use the graph to find the slope, my rise. Okay, how far up do I go between these 2 points? Well, here I'm at 0, and I'm going up to 24.5. So for my slope, if we think a slope is rise over run, I rise up 24.5, and our run is going over 7. So we'll grab our calculator out, simplify that, 24.5 divided by 7, we get 3.5. So my slope is 3.5. Okay, let's go ahead and let's put that in. Y minus, I'll be at least another 10 minutes, Rio. Y minus, okay, which one of these points we want to use? 0, 0 or 7 and 24.5? To me, 0, 0 seems easiest because they're 0, so let's plug those in. My slope is 3.5, and x minus 0. So let's see, let's simplify that. Y equals 3.5x. Hey, so there is my equation. So we answered the first part. And then it says, and interpret the slope. Okay, so what does the slope mean, 3.5? 3.5 what? We want to interpret it in terms of the problem, of what's going on here in this problem. So let's go ahead and let's go back here to our rise over run. Our rise, again, is distance. So this is our distance. And our run is time. So this gives us distance over time. And again, our distance is in miles, and our time is in hours. So here, this 3.5, again, is miles per hour, because this is 24.5 per 7 hours. This would be 3.5 per 1 hour. So to interpret the slope means that she is traveling at 3.5 miles per hour. So the slope in this case, the slope is her rate, how fast she's going. She's going 3.5 miles per hour. All right, in this last very question, how long does it take Allison to hike 14 miles, traveling at the same rate? Well, 14 miles, that's distance, agreed? And our distance in this problem is our y. So I know this is my y value. My distance is 14.5. So let's just go ahead and let's use our equation here. If y is 14, what is my x, my time? Because they're looking how long. They're asking for the time. So 14 equals 3.5x. We divide both sides by the 3.5. X equals, let's see, 14 divided by 3.5. We get 4. So x equals 4, and that's in hours. Okay. All right, example 2. All right, 2 prom venues charge a rental fee plus a fee per student. The table shows the total costs for different number of students as Lakeside Inn. So the table here is at a hotel called Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented by this equation. So Sunview is this equation, Y equals 10X plus 600. Where again, X is the number of students, and Y here is the total cost. Which venue charges less per student? How many students must attend for the total costs to be the same? Okay, let's go ahead and let's just look at the Sunview one because we have an equation for that one already. So the total cost is Y. 10 times X, where X is the number of students, plus 300. So if you think about it, if one student went, it would be 10 times 1, 10 plus 610. If 2 students went, it would be 10 times 2, which would be 20 plus 600. If 3 students went, so according to that model, it looks like that $10 is how much they're charging per student. So their slope there is the charge per student, because remember that 10 right there is our slope. Plus they're going to add an extra $600 on for, I don't know, extra fees or whatever for the rental fee. But we don't have an equation for Lakeside, so let's go ahead and let's find an equation for Lakeside. Okay, so let's find our equation, much like we did the last one. So let's do ordered pairs. We have 1, 2, 3, 4, 5 different ordered pairs. So let's just go ahead and let's just pick a couple. Let's do the first two because those numbers are smaller. 100 and 1500. There's one ordered pair. Next one is 125 and 1800. Okay, so we know 2 points, so let's use point slope form, y minus y1. Okay, first things first, let's find the slope. Again, the slope is the change in y over the change in x. So let's see the change in y. How much is it changing? Well, 1800 minus 1500. I'm going this one minus that one. Now the change in x, 125 minus 100. There's my change in y. So let's go ahead and let's 1800 minus 1500. I'm going to do it all in one step. So I put that in parentheses, divided by that in parentheses, 125 minus 100. Looks like 12. Okay. So y minus, and now we use one of these 2 points for our x1, y1. So y minus, let's use this point. So that's my y minus 1500. 12 is my slope, x minus 100. Okay, y minus 1500, 12x minus 1200. Subtract the 1500 to the other side, plus 300. Okay. All right, so if we look at, it's asking which venue charges less per student. So this one was $10 per student. This one is that 12x plus 300. So this one is $12 per student. So Sunview charges less per student. Answer the first question. Which venue charges less per student? How many students must attend for the total costs to be the same? So again, this is the total cost for Sunview. This is the total cost for Lakeside. I want to know how many students will make these two things equal. So what x's do I put in to make this equal to that? I could guess and check, or I can just set them equal to each other and solve. 10x plus 600. Want to know when does that equal? 12x, running out of room, plus 300. Okay, so let's subtract the 10x over here, so it'd be 2x plus 300 equals 600. Subtract the 300 over, 300 equals 2x. Divide both sides by 2, x equals 150. So 150 students would have to go to make the two places cost the same. Because again, this one is charging more per student, but has a lower rental fee. This one is charging more per student, less per student, but has a higher rental fee. Example 3. Okay, what I'd like you to do now for example 3, I'm going to walk you through the steps on how, I want you to see how to do a linear regression or come up with a line for real life data by hand, but it's quite tedious and not exact at all. So what I want you to do right now is I want you to pause this video, go into your dynamic ebook, and watch the example video on page 24 for example 3. Okay, I want you to watch that video and just watch it, pay attention to what they're doing, and then come back to this one and we'll finish that up. Okay, hopefully you went and watched that example 3 video. And again, they're basic steps. Plotting the points, drawing a line that looks like it fits, and they end up getting, I believe, this line, right? Y equals 0.5x plus 1. And then, so they use a line to estimate how much it would cost for a smoothie with 8 ounces of fruit. I think they got $5. Okay. The one thing with their method and doing it by hand is it's not exact at all. It has a lot of room for error. If your line that you draw in is slightly different than somebody else's, then this equation would be slightly different, then this number would be slightly different. And sometimes that slightly different is off by a lot, depending on what line you think best fits all the points. Okay, so they're statistically, using statistic tools, which we'll get into that towards the end of the year, there's a better way of finding that line of fit. And that's using the line of best fit, the one that fits the closest. And there is one line that will fit the closest. So it's a line that lies, the closest to all the points. Okay, and there's a way of finding it by hand, but your calculator has such great tools for doing this. So I'm going to walk you through the steps on how to use your calculator to find this line of best fit. Okay, first things first, we need to put our data points in our calculator. So over here, do you see we have this table? So I'm going to actually put this table in our calculator and plot those points. So to do that, we're just going to jot down steps. I need to hit my stat button. Okay. Your stat button, which is located right there. See stat? and I want to edit my statistics list, so edit. Okay, now I have where I can put list 1, list 2, list 3, and so forth. If you have things in here, okay, if you have stuff in your list, arrow up to where you have list 1 highlighted. Don't hit delete, but hit clear and arrow down, and it will delete everything in that list. I don't have anything in mine, so I don't have to worry about that. So now I'm going to come over here to list 1, and I'm going to plot all my X's in list 1. So my X's are going to go here in list 1. Okay, so we'll just type them in 2 and enter after each one. 1, enter, 4, enter, 7, 10, enter, 3, 6, 9. Okay, now arrow over to the right, and you see it automatically jumps over and I'm across from 2. So now I'm going to type in the Y that correlates to this list 1 to 2. So my list 2 is going to be my Y's. So 2.1, 1.5, 3.05, 0.45, 5.95, 1.75, 4, and 5.35. And again, make sure you end at the right spot so that way your X's are directly across from the Y that goes with them. So now that I have them in there, I want to plot them so I can see them. So I need to turn my plots on. So to do that, I'm going to go second. Do you see there's a stat plot right there? So second stat plot. Okay. Okay, and see all my plots are off. Plot off, plot off, plot off. So I'm going to hit enter, and I want to turn this plot on. So I'm going to hit enter onto on. And then there's all kinds of different plots I can do. I can just do dots. I can connect the dots. I can make a bar graph out of it. I can make a box and whisker. We just want to do a plain dot plot. Leave it set for that. Now here it asks me my X list. Where are my X values? Well, our X values are in list 1. So our X values are list 1. Our Y values are in list 2. And how do we want to mark it? Do we want to mark it with a little square, a dot, a plus sign? We're just going to mark it with the little square. Now when I go to graph, sometimes you can see all the points, sometimes you can't. You also need to make sure, go to your Y equals, make sure there's nothing in there. Clear out whatever's in there. Hey, to make sure we can see all of our points, I'm going to do a zoom. So we're going to go to zoom and then down, and there's actually a zoom stat option, option 9. So zoom and then zoom stat. Basically that just zooms your window so you can see all of your statistics. So there's all our points. So there's all these points in a scatter plot. Now we want to find an equation for that line. So again, we go to stat again, but we don't want to edit with our statistics, we want to calculate with it. So we're going to go over to calculate. So stat, then over to calc, okay, and then we're going to arrow down. We want to do a linear regression. We want a line that fits these points. So either arrow down or hit option 4. Okay, now it's asking you, okay, where are your X's? My X's are in list 1. Where are your Y's? My Y's are in list 2. Okay, frequency list, ignore that one. But now this one, store regression equation, meaning once I have the equation, where do we want it to store it? Where do we want it to put it? So I'm going to have them put this in my Y1 so I can see the graph right away. So we're going to go to store regression equation, and then I'm going to hit my vars button. We go to vars, and then to Y vars, because we want Y variables, and then function, because we want our functions, and then Y1. Okay, you could graph it in Y2, you could graph it wherever, but we're going to graph it in Y1. And come down to calculate, hit enter. So there is our linear regression. So again, y equals ax plus b. Remember, that's our mx plus b, where a is 0.5054, my b is 0.8650. So my equation for this ends up being y equals my m 0.5, we'll go to two decimal places, 0.51x plus 0.87. So now if you look at the one we did by hand, 0.5x plus 1, that is pretty close to 0.51x. But again, this one is the line of best fit. It fits better than this one does. It's closer to more of the points. Okay. Now, if you notice, there's also these other two values here. There's an R2 and an R. And we're going to ignore the R2 for right now, but the R value is what we call that correlation coefficient. So that's that R value. This tells you really how close are your points to that line. Okay, the closer you want your R value, the closer it is to 1, or -1, the better it fits. Okay, so if this R value was exactly 1, then that tells me that this line goes through every single one of the BAT points I plotted. Okay, so it fits the data, real life data perfectly. Okay, that's that R value. And we're going to practice doing a couple more of these